Hey, my name is Sandra, and I'm going to be showing you the basics of writing IPv6 addresses and how to establish simple routing in a network using IPv6. Before we get into this routing situation you see right over here, we're going to start with a brief overview of IPv6 fundamentals. Alright, so to start off, we have two addresses here. We have IPv4 at the top and IPv6 at the bottom. And the most noticeable difference between these two is the spacing. So IPv4, it is 32 bits and is expressed in dotted decimal notation here, compared to IPv6, where there's 128 bits in length and it's written in hexadecimal notation. Right now this address may look a little bit intimidating just based on the size and the length of it, but I promise you, once you know a few simple rules, it will make networking and subnetting IPv6 addresses so much more easier. Alright, so the first rule to help you compress IPv6 addresses is omitting the leading zeros in each hextet. So here we have a preferred format, all zeros. I have bolded these zeros in each hextet that are leading that we will just remove. And what you're left with is just 1 0 left over in each hextet. Looking at a more realistic address, I also bolded the leading zeros in each hextet, and that is what you are left with. It's pretty simple, makes it much more easier to read. It's very important that you only remove the leading zeros in each hextet, because otherwise the address would be ambiguous and then it just would be a bad time for everybody. To compress IPv6 addresses even more, we have rule number 2, where we can omit all 0 hextets. And to do that, we represent it by a double colon. So here's a preferred format. We have what we see here, a contiguous string of 1 or more 0 hextets. All hextets are in zeros, so all we have to do is represent this line of string right here with 2 double colons. If we look at this more realistic address again from our previous slide, we have what our leading zeros were omitted. You can see this is a string right here of zeros in the hextets, and so once you omit the leading zeros, you have just these 3, and then you can add the double colon to represent those as well. The prefix notation in IPv6 is a lot like IPv4, where it's written in the classless interdomain routing, or what we pronounce it as CIDR notation. Prefix length is a decimal value indicating the leftmost contiguous bits of the address, or what I like to call is the network portion. So as we see here, the first 4 hextets, each hextet is 16 bits, and that makes 64 bits for our network portion, and we represent that by writing the /64 notation at the end. If you like to break this down even more, the first 3 hextets here is considered the routing prefix, and then we have the 4th hextet right here, the 0001, would be considered our subnet ID, and then we have the last 4 hextets here is all dedicated towards the host ID, and that makes up your IPv6 address right there. So after learning more about prefix notation and rules 1 and 2, we took this long mess and we turned it into a nice, clean, compressed IPv6 address. So now that you know some brief IPv6 fundamentals, I will show you some routing with IPv6. So the first thing you should know before you start routing with IPv6 is that it won't work if you put in any addresses into your router, because your router is already set to disable IPv6, so we will have to enable it. So to enable IPv6, we're going to go into the router CLI. Go ahead and hit no on the configuration dialog. Go into enable mode, global configuration mode, and from there we're going to write IPv6 unicast routing. Pretty simple. Exit that out. Alright, so now we have IPv6 enabled on our router. So if we want network 1 and 2 to communicate with each other over IPv6, well, the first thing we're going to have to do is establish the IPv6 addresses for both networks. So what we're going to do is go into your router, And you see we have gigabit Ethernet 0, 0 and 0, 1, so we're going to go ahead and establish those. So for network 1, we're going to have this address on our G00 interface, and it'll be under this subnet 1. So in your router, go ahead and go into configuration mode again. And then we're going to go into our interface G00. And from there, we're going to enter our IPv6 address. IPv6 address, and then we're going to type exactly what we have written over here. 2001 DB8 AAAA 1 double colon 100, and add that 64 notation. And then we're also going to put no shutdown for there. Alright, so we have our first communication going on network 1. We're going to do the same thing for our other interface. Go into configuration mode again. It's G01. And then from there, you can just use the arrow keys to go back to your address. And we are simply going to change the subnet from a 1 to a 2. Just like that. You can see it's the same that I've written here. Enter that, and no shutdown as well. And there you go. As you can see, we have all green communication. It's looking good. But for PC1 to communicate with PC3, we need to make sure it has the correct address. So go ahead and click on that PC. Go ahead and go to IP configuration. And right now it's at static. We're going to go to auto configuration. Each PC always has a generated link local address, and as you can see, they take this link local address and it kind of like makes its own manual IPv6 address. So you see 2E0 starts there, and here is our global unicast part of our address right there. We're going to go ahead and do the same thing as we did at PC1, is auto config PC2 and 3. IP configuration, auto config. Grabs the IPv6 gateway as well. PC3, auto config, saves that. We're going to do just simple ping test to make sure everything's working. PC1 can in fact reach router. PC2 as well. PC3 successful. And then the final connection, PC1 to PC3. Successful. So we do have a successful connection between network 1 and network 2. Another way you can test pings is you can go into PC3, for example. You can grab the link local address. Go ahead and copy that. And then what we're going to do is rewrite it with our global address when we go into PC1 right here. So if we want to ping PC3 from PC1, go onto a command prompt, write ping, paste that link local address on PC3, but we're going to change FE80 to the beginning of our IPv6 address. Let's go ahead and move that to 001. Colon, DB8, colon, AAAA, colon, and PC3 is on the second subnet network. And ping that, and we have successful replies back from PC3. And that is how you successfully do IPv6 routing on a simple network configuration. Thank you.